Alright, good day to you. I hope third quarter was a success. We are now in our Unit 9B. We're starting at 9.5 here. Graphing irrational functions, which means graphing that stuff with fractions, stuff on top and the bottom. We're going to figure out how to graph them. Alright, so here, this is an example of one of the graphs and what we started with here. So let's just kind of look at what's going on and what can we make sense of. First thing we might want to notice is there's two asymptotes. There's the vertical one here and the horizontal one. Well, where are they at? Our vertical one, this is at x equals 2. Alright, well the vertical, that means we're never touching there. That means this is a number I cannot plug in for x. I cannot plug 2 in. I can't figure out what f of 2 is because it never goes there. Why? Well, that's because if I plug in 2 down here, the bottom of my fraction would be 2 minus 2, which equals 0. Am I allowed to have something over 0 in a fraction? No. If we did, the world would descend into chaos, which I decided a moment ago should be the next horror movie. In a world where you can divide by 0. It'd be crazy. Nothing will work. So we can't do that. So it can't happen, so that's why our vertical asymptote is when the bottom here equals 0. So our horizontal asymptote goes through here, which is 3, and that's going to be y equals 3. Well, y equals 3, where do we see a 3 up here? It's this number. That happens to be these front numbers. 3 over 1 gives us that 3. Why does that happen? Well, this is, if you imagine these things going out forever and ever and ever, is what our graph is going to get really, really close to as this number gets really, really, really big. As it gets closer and closer and closer to a positive infinity. That was one of the worst infinities I've drawn in a while. There we go. So, what you got to think about is, if I plug in numbers like 1, 2, 3, 4, they're not that big. That means that adding 4 or subtracting 2 makes a difference. If you only got $1 and I'm either going to add 4 to it or subtract 2, that makes a difference to how much money you have. Alright, so those numbers kind of matter. Now as this gets really, 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 really big, let's say we're plugging in, $1 billion here. A billion. One with all kinds of zeros. If you had $1 billion and I told you, hey, I'm either going to give you 4 or take away 2, would you really care? No. These things start to not matter. So as this number gets really, really big, these things become almost meaningless. They don't matter anymore. It's whether you're just barely on this side of the asymptote or barely on this side of the asymptote. Just barely above or barely below. But you get really, really close to it. It doesn't matter whether you're just barely above or barely below. You're so close to it, infinitesimally close to it, that it doesn't matter. So that's why these are the only things that matter. Because if these don't, the x's go away, and all you're left with is 3 over 1. So as your number gets really big or really small, everything just starts to smush towards whatever your coefficients are here. Because they become the only things that actually matter. It's kind of cool if you think about it, but I'm sure you won't. Why would we think? I don't know. Alright, so x-intercept. That, in this case, happens to be this number right here. Well, how do we solve for x? Well, that's when y is going to be 0. So that means this is a 0. If 0 equals a fraction, what has to happen? Well, then the top has to equal 0. Doesn't matter what's on the bottom, any 0 divided by anything is going to make that 0. So if I'm going to get y at 0, because that's our x-intercept, that means the top has to be equal to 0. And in that case, you set this over 4 divided by 3, and you get this little negative over here. So that's where that comes from. And lastly, what's left here? Oh yeah, our y-intercept. Y-intercept right here. Well, our y-intercept is when x is 0. We didn't go left or right. Well, if x is 0, that means these things go away, and we're left with just those back numbers. 4 divided by negative 2, negative 2. So that's where all of the key information is that's going to come from as far as how to graph these and what we're going to do. I would highly suggest taking a moment writing these down. It's just what I talked about, your vertical asymptote. Nobody really remembers all these letters necessarily. It's kind of tough. It's a lot to think about. So remember, our vertical asymptote's when you take your bottom and put it equal to 0. Our horizontal, those are those front numbers. These ones right here. Our x-intercept, that's when the top equals 0, right here. and our y-intercept are the back numbers here. So it's kind of like we've got every little thing that you can do here. The front numbers, the back numbers, the top to 0, and the bottom to 0 all give you some information. So you just got to keep straight which ones do what. And if you kind of have an idea of why those things are happening, like the bottom going to 0 can't happen, that's why it's a vertical asymptote, then you can kind of start to remember why these things work, and you'll be able to do alright on the test. This bottom thing here, that's a little formula. You take this number and subtract these two multiplied over that one, and if it's positive, it's going to be normal. So positive, the graph's going to look like this. If it comes out negative, it's less than 0, then that means our graph kind of flips and becomes the other quadrants. And it's over here in the top left and the bottom right. I'm going to say every time you're going to be able to tell based on your two intercepts where it's going to go, because they're already going to put you in the right quadrants. Alright, so let's start getting to work on these. Vertical asymptote, take your bottom equal to 0, x minus plus 1 equals 0. We have to subtract 1 over, so we get x equals negative 1. So my vertical asymptote is at where x equals negative 1. So I'm going to draw in my vertical dotted line here. Horizontal asymptote, those are our front numbers. 1 and 1 here, because of my coefficients there, it's just 1. So we're right here at this one. Get our lines going there. X-intercept is going to be when our top equals to 0. So x plus 4 equals 0. Subtract your 4, so x equals negative 4. So here's negative 1. I got negative 2, 3, 4. That means our graph is going to go through negative 4 over here. Y-intercept are our back numbers, which are also just going to be 4 over 1. So it's just 4. 1, 2, 3, 4 goes there. So that's all the information that we need. I already know my graph is going to be in this top right and the bottom left because I've got intercepts there. But for the first couple, I'm going to check this anyway here. We got a 4 minus a is 1 times d is 1 over c, which is also 1. So it's really just 4 minus 1 equals positive 3. Now since this is positive, that means it's normal and we're not going to flip, but we already knew that anyway. Let's go with green here. Alright, so now my graph is going to go swoop like this, and swoop like, oh, that was kind of ugly. Yeah, put an arrow on it, makes it okay. Alright, there we go. There's our first graph. Alright, this one, vertical asymptote. Bottom equal to 0, so x minus 3 equals 0, that means it's going to be negative 3. Horizontal asymptote, again, is going to be at 1. So negative 3, 1, 2, 3, and at 1. So we've got our asymptotes going. X-intercept is when our top equals to 0, so that's x plus 2 equals 0. Subtract your 2, so x equals negative 2. For my x-intercept, that's right here. Y-intercept is going to be the back numbers, that's 2/3. Now we get scared, but we just need to decide, is 2/3 below or above 1? 2/3 is less than 1, so it's going to go right here. So now both our intercepts are going to be for the curve on the bottom right. Our other curve is going to be up here in the top left. Let's solve for that anyway, though. This will be my last time doing this guy because we're always going to know anyway. 2 minus 1 times 3 over c, which is 1. So we get 2 minus 3 is negative 1. So that comes out negative. That means it's going to be a flip. But we already knew that because we knew this one was going to be right here. It's an ugly curve, and our other one was going to be right here. And that's a pretty curve. It's easier when you don't have the dots to have to go through. You just whoop, throw them right through there. Alright, example 3. Alright, vertical asymptote, bottom equal to 0. So we got 2x minus 8 equals 0. Add our 8 to both sides. 2x equals 8, divide by 2, and x equals 4. So our vertical asymptote is going to be at where x equals 4. 1, 2, 3, and 4. Horizontal is our front numbers, and that's going to be at 1/2. So if my 1 is right there. It's going to be right in between, and this is getting really ugly. Real ugly. X-intercept, top equal to 0. That's x minus 8 equals 0. Add 8 to both sides, so it's just 8. And y-intercept are the back numbers. They're the same, negative 8 over negative 8, so that becomes positive 1. So, positive 1 for my y. X-intercept's at 8, so this is 4, 5, 6, 7, 5, 6, 7, 8 here. So now I already know that this is going to come out to be a flip because my dots are in the top left and the bottom right. So we draw in our awesome little curves. Shoop. And we're good to go. Awesomeness. Alright. Once you give 4 and 5 a try on your own, remember if there's nothing up here, it's kind of like it's x plus 0 on the top. See what you can do on your own here for 4 and 5. Go ahead and hit a pause, try them, and then we'll look at these last ones with some weird examples. Alright, this guy. Number 6, it's like I got a plus 0 here. Gonna kind of fill in this stuff here real fast. Alright, so that looks good. Vertical asymptote, solving right here. Add your 4, divide by 2, and get x equals 2. Horizontal is just 3 over 2, the front numbers. X-intercept, you take your top equal to 2 right here. It's 3x, equal to 0. So 3x equals 0. When you divide by 3, 0 divided by 3 just makes 0 still. And our y-intercept is also the back numbers, which is 0 over 4. Oops, negative 4. So that also is 0. So we've got all our stuff. That means we're going through 0 here. I've got my 2 intercepts here at the 3 halves and at the x equals 2. So since my dot is here, that means I'm definitely in my bottom left. Swoop. And my top right. And there we go. That's it. The nice thing about getting that 0 back here when you just have like 2x or 3x on top is you know both of these are going to be 0 because all your fractions are going to come out 0. Makes it nice and easy for you. Alright, let's go. Alright, so I got a vertical asymptote here, solving our bottom for 0 gets the negative 1/2. That'd be this guy right here. Horizontal asymptote, 1 over 4, vertically or horizontally right here. X-intercept and y-intercept, since we have that 0 on here, means they're both going to be 0. And since my intercept is at 0, I got one curve in this place and one curve. Oh geez, these are just getting worse and worse out here. Exciting stuff. Alright, couple more. And there we have all our stuff. We solve our bottom to get our vertical. 2 over 3 here. Solve the top to get our x-intercept and our y. All the fractions are kind of scary, but they're just all little tiny things. So you just put your dots in here and kind of worry about where all they're going to look. It's okay. So this guy is going to go like so. And that means the other one's got to be out here, up top. Alright, we got one last one to look at and we're all good. Alright, and our last guy here. It's interesting because the bottom has basically x plus 0. So my vertical asymptote's going to be at 0. Cool. But what that means when we get to our y-intercept, we're going to have 2 over 0, which means that's undefined. You can't divide by 0, which means there is no y-intercept because our graph always just gets really close to it and never touches it. So it does not exist, which, I don't know, that's cool, interesting. And that's it. Good luck to you. Make some good choices, and we'll see you later.